So we'll continue from the class 3. I'll take a problem something like this. A triangular prism of 30 mm base edges and a height of 70 mm is resting on one of its base corners on HP, such that the longer edge containing that corner is inclined at 45 degrees to HP, and a plane containing that edge and the axis is inclined at 30 degrees to BP. Draw its projections. We'll see how to solve this problem. Since the face is resting on one of its base corners on HP, I'll go for drawing my first view because it's resting on HP. I'll draw my first view on HP having one of its corners on the right side, something like this. If it's a square prism, I'll construct a square like this. If it is a pentagonal prism, a pentagon to have a corner on the right side. If it's hexagon, again a corner on this, right? Okay, so that edges containing that corner should make equal inclination with the vertical line. In that way, I have to draw, not with some other inclination. So they should equally incline to a vertical line. So this is the problem position. So I'll draw this position. So ABC, A1, B1, C1. I'll project this to a height equal to 70 mm. Then A dash, B dash, C dash, A1, B1, C1. Then project the axis with the chain line. You represent the axis. So if I bend this axis, so this is the view. So in the top view, front view, it looks like this. So then you have to, the axis now is perpendicular to HP. You have to incline that to, says it is inclined at 45 degrees to HP. So in this case, it says the longer edge containing that corner. So longer edge is nothing but this is the C1. So longer edge containing this corner where it will going to rest on HP C1 is nothing but this. So I have to draw in such a way that the C7 makes an angle of 45 degrees. Then I can go for drawing that C7 line inclined at 45 degrees, and that I will just take that length and will make it dark. Then I will construct this rectangle, this line. Okay. So then the axis will reproduce the same thing, just transferring the lengths. So I'll redraw the same view. So this is satisfying this condition where he says that the longer edge containing that corner is inclined at 45 degrees. So longer edge containing this corner CC1. So that is CC1 containing that corner C1 which is resting on HP. He says it's inclined at 45 degrees. Then I can go for drawing this. The same problem can be changed. So this sentence can be changed like this. Since the C1 is parallel to the axis, so even you can find a problem saying that the axis is inclined at 45 degrees to HP instead of this longer edge containing the corner inclined at 45 degrees to HP. Or you can have the base inclined. If the longer edge is inclined at 45 degrees, so since these two are perpendicular, or if the axis, see the longer edge and the axis will make same inclination because they will be parallel always. So then the base is at 90 degrees to this. So the base is at 90 degrees, so this becomes 90 degrees. So these two becomes now total angle will be 90 degrees. If the axis is inclined at 45 degrees, so this will be 90 minus 45. The base will be inclined at 90 minus 45. So that will be 45. If it is 30, 90 minus 30, so 60 degrees. So that way this will be at 90 minus axis inclination. So I can go for constructing even the base. In that case, they can give you saying that the base is inclined at 45 degrees to HP and the plane contact, in that way they can give you. So you can have three different types of problems by changing the sentence here, but the solution remains same. So project this. So after projecting all the points from the front view, draw locus from all the points, locate the points A, B and B, C and C, O and O, then A1 and A1, B1 and B1, C1 and C1, and O1 and O1. So all the points. Then to identify which edges are visible and invisible, look from the top, check out which end face is visible. So this is nearer to you, so the nearer end face is visible. So you can reach all the points of the end face. So complete all the edges of that end face with a thick continuous line. Then you go for the outermost edge outermost edge and outermost edge. So if you complete, so A1, B1, B, it becomes a surface. On that surface you cannot have a dark line because A1, C1 and this is not joined. Okay, you cannot draw a dark line because there will not be any edges on this surface. So that should be a plane surface. In that case, so these edges actually comes below that surface, that becomes invisible. Go for joining them with a dotted line, invisible edges. So the axis only up to that you can set axis. So since he says the plane containing that edge and the axis is inclined at 30 degrees to VP, so imagine a plane here passing through that. He says that plane which is now parallel to VP and perpendicular to HP, he says that should be inclined at 30 degrees to VP. Then you have to redraw this solid containing that edge and the axis to incline at 45 degrees. So then directly draw at 45 degrees. So redraw this view by inscribing in 1, 2, 3, 4 rectangle. So toward 45 degrees, then draw a line perpendicular to this. So mark 1, 2. So complete this 1, 2, 3, 4 a rectangle. On that you can take 1 to A, get that point, 2 to B, then C is here. So A1, B1s and this, you can easily redraw this, okay, all the points. Then you project all the points to get the front view. Draw locus from all the points, locate all the points A and A, B and B, C and C, A1 and A1, B1 and B1, C1 and C1. Then look from the bottom and look from this top view. So now the base is nearer to the observer compared to this. This is closer to you compared to this. So then the base edges are visible. Complete all the base edges with a thick continuous line. Then you go for the outermost edges. All edges, outermost edges are visible. So complete all them with a thick continuous line. Then this is B1 and B is the end point of this B1. So if you can see, B1 is the outermost point on the outermost boundary, and if this is the visible end face where the other point is visible. So if we can see both the end points of a line visible, so complete length is visible. That way you can make this line a thick continuous line. Or you can see here, this is the nearest edge to the observer where you can reach all the points. So you can see this edge B1, so that becomes visible edge. In that way you can cross check even here. So then you go for making it with a thick continuous line. Then this complete area becomes, this complete area, the boundary area becomes visible surfaces. So any edge now within the visible surface will be a dotted line, because you cannot have a dark line on this visible surface. This is again a surface. You cannot have a line on the surface, right? Okay. So you cannot have a line on the surface. So there will not be any edge on the surface. It's a plain surface, right? So then you go for joining that with a dotted line. So this is the solution. So in this case, actually, if you find a problem where they say that the axis in the second case, if the axis is inclined at 30 degrees to VP, so then the given angle will be actually the true inclination. Whereas if in the second position, if the projection of the axis, the top view of this is becomes apparent length, you cannot take that apparent length with the true inclination what will be given in the problem. So in that case you have to go for finding beta. Whereas there are three conditions where you need not take beta. One is this, a plane containing the edge and the axis. Even though the axis is apparent here, because it says the plane is inclined, just incline that plane, that solid itself in that particular plane, and you redraw. So otherwise you have to take beta for this if that sentence is not given. So these are the three sentences where you need not take beta, even then the projection of the axis in the second view becomes apparent length. So whenever you have apparent length, if the given inclination is the true inclination, then you have to go for finding beta. So whereas if you find these three sentences, so there is nothing but yes, given beta directly. In that way you need not take beta again. So directly you can draw with the given inclination. So if you find the sentence with that inclination, if you find these words along with the inclination. So in that case now you're going to find a problem, something like this. A pentagonal prism of 30 mm base edges at the height of 70 mm is resting on one of its base edges on HP such that the axis is inclined at 30 degrees to HP. In that case you can give it the axis or the base, I said, or rectangular the rectangular surface containing that edge on which it is resting is inclined. In that way, it can give you one inclination. So in that case, when you incline the solid this position, the same way what I find here, no, longer edge containing that corner. If you have an edge, then you're going to have a rectangular surface containing that corner. In that way, they can give you. So in all the cases, the first inclination will satisfy with HP, and the projection of that will be apparent here. So the second sentence, they will say the axis is inclined to VP. Instead of that, if we give something like this, axis appears to be inclined at some degrees to VP. So it says appears to be inclined at 30 degrees to VP. Instead of giving axis inclined at 30 degrees to VP, it says appears to be inclined at 30 degrees to VP is nothing but the apparent inclination, beta directly given. In that case, even though this length becomes apparent, you need not go for finding again apparent inclination, because the given inclination is nothing but the apparent inclination. So you need not take beta for this problem whenever you find this sentence along with the inclination with VP. One more condition where you need not take beta is the top view of the axis is inclined to VP. So the top view of the axis is nothing but this apparent length. He says that is inclined. So the top view of this is inclined. Just incline the top view. The given inclination is nothing but the beta. So he has given directly the beta. So where you have to rotate this to that particular angle. In that case, you need not take beta again, because he says the top view of this axis is inclined in that way, not the true length of the axis. He says top view of the axis is the apparent length. That apparent length is inclined. So inclination of the apparent length is nothing but the beta only. So in that case, you need not take beta, directly go for drawing this. Otherwise, the third sentence is the plane containing that edge and the axis, something like this, where the plane containing that edge is inclined, and the axis containing the edge and the axis is inclined that with the given inclination. Otherwise, you have to take beta. So I'll go for taking a problem where you have to find beta. This is the one. Okay, I'll just take again a triangular prism and say this is the problem. If we have a problem something like this, a triangular prism of 30 mm base edges and a height of 70 mm. It need not be a triangular prism, it can be any prism, the same procedure. I am taking the triangular prism because it's I have drawn this because it is very easy to draw, because only 3 lines. Okay. Otherwise, you can adopt the same procedure for any prism. The procedure remains same. Okay. Only instead of triangle, you're going to have a pentagon. For pentagonal prism, you're going to get different 5 edges. Hexagon, 6 that way. Okay. Otherwise, same. So we'll go for this problem only, triangular prism. A triangular prism of 30 mm base edges and a height of 70 mm is resting on one of its base edges on HP such that the axis is inclined at 30 degrees to HP and 45 degrees to VP. So axis is inclined at 30 degrees to HP. I told you this can be given in 3 other formats. The rectangular surface containing that edge on which it is resting is inclined at 30 degrees. This is the rectangular surface that will be parallel to the axis, so the same inclination can be given. The base will be inclined at 90 minus this axis inclination. In that case, he can give you the base is inclined at 60 degrees to HP. The same view again, because if base is inclined at 60 degrees, axis will be inclined at 30 degrees. So instead of giving axis inclined at 30 degrees to HP, you can give you the base inclined at 60 degrees to HP. The same view will draw, and when you project this, you'll see that the projected length will become apparent length here. So then this will be the apparent length, whereas here he says that is the axis is inclined at 45 degrees to VP. So the axis is inclined at 45 degrees is the true inclination. Always you have to give the true inclination to the true length of the line. Whereas here this is apparent, you cannot give the same inclination. Instead you have to go for finding apparent inclination for this apparent length. Okay, because this length is apparent here, you have to go for finding beta, because you don't find that sentence appears to be inclined at 45 degrees. No sentence. Instead of that, he says and 45 degrees to VP. Without that 3 sentences, what I said, appears to be inclined. Top view of the axis is inclined at 45 degrees. The projection of the axis on HP is nothing but the top view. Top view is inclined at 45 degrees. The plane containing that edge and the axis is inclined at 45 degrees to VP. No sentence of that particular type. In that case, when you go for satisfying this second inclination, if the length is apparent, then you have to go for finding beta for this. if we don't find the 3 words, right? So we'll go for solving the problem. So anyway, I have drawn this before. Yes, okay, so we'll go for, because it says that a triangular prism is resting on one of its base edges of HB. So we'll go for the edge position. We'll draw this edge. Now on this edge, I'll construct my polygon depending upon the prism. Whether it's a square prism, I'll construct a square. Pentagonal, I'll construct a pentagon. If it is a hexagon, I'll construct a hexagon. So that way, if it is a rectangle, I'll construct a rectangle about this edge. So that I have to make that edge perpendicular to XY line. So that when I bend towards right, that should rest on that edge. Okay? So I have to keep in this way. When I turn towards right, it should rest on that edge. See? It will going to rest on this edge when I turn. Okay? So now because it says the axis is inclined at 30 degrees, so axis will be parallel to the surface. So we can go for drawing this base inclined at 60 degrees. I can take this length, mark here, I can redraw this rectangle here, so that if the base inclined at 60 degrees, when I mark the axis taking this length, mark it here, draw the axis, then I project, see that the axis automatically makes at 30 degrees, because if we take 60 degrees here, this will be 30, this will be a right angle triangle, because base of the axis will be mutually perpendicular. This is 90, so these two should be 90. This is 30, this should be 60. This is 45, this should be 90 minus 45. That way, so this is 30, so I have to redraw this same view, then project all the points on HP, draw locus from all the points, then locate A and A, mark the point you name it, B and B, mark the point you name it, C and C, mark the point you name it. So O, in the same way, go for now. This is A1 and A1, so this is A1. A1, B1 is the edge which is resting on HP, because it says it's resting on one of its base edges, A1, B1 on HP, so it's touching XY line, it's nothing but resting on HP. So B1, B1, so C1, C1, same way. Then I'll look from the top, check out which end face is nearer to you. So ABC is nearer to you compared to A1, B1, C1, so top end face is nearer to you compared to this. See, this is away, this is very close. So then I can complete that base edges, that end face edges with a thick continuous line, because if I can see the end face is nothing but I can see all the edges of that end face. Then I'll go for the outermost edges, join this. So outermost edges, join this, join, then join this edge, so this becomes a boundary. Now see CC1, if this is the end of CC1, I have to check whether I have to join with a thick line, continuous line, visible and invisible edges. So C is visible and C1 is the outermost corner which is visible. So then if I can see the two endpoints of a line is nothing but I can see the complete line. Then I can go for making that with a thick line. That is the visible edge. So if otherwise if I look from the top, that's the topmost edge where I can see this CC1. See, I can reach all the points of this. So once I complete, okay, so this becomes the surface. So then this is a line which is not joined. I cannot draw a dark line here because there will not be any edge on the surface. So then that is nothing but the edge which is below the surface. That becomes invisible edge. So we know how to represent invisible edge, a dotted line equal. So dashes with equal lengths with equal space in between, right? So now this is the apparent length. The projection of this axis will be apparent. Because I don't find that series sentences, I have to go for finding beta now. To find beta, this is the procedure. Draw a line inclined at 45 degrees. I'll explain here again. The same thing. So from XY line, draw a line inclined at 45 degrees, true inclination. On that, you take the true length of the line. So true length of the line, mark this. So if it is 70 mm height, you take that 70 mm height from this point. One end point, let it be an XY line. Okay. So this is the true length of the line. Right? Same thing. So the true length endpoint, you draw a locus parallel to XY line. So if I draw a line parallel to XY line, so then if you take this apparent length which will be less than this length, okay, so this is bigger whereas this projected length becomes shorter. So if I taking this point and if I cut on that locus, see, taking that one point fixed here, and this length will be less than this, right? Okay. So this is the true length and less than that. So when I draw, it is going to cut on this. So now say this is the point where it is cutting, so taking that length, okay, so then line joining from this point to this point will give you the apparent angle. See, this angle will be more than this angle from here to here, from this angle. So this is more, right? Okay, this is more by this angle. See, same thing here. So drawn a line, true inclination of 45 degrees, taken true length of 60 on this, drawn a locus here parallel to xy line, then taking this apparent length which is less than this length, I have drawn an arc, so that's cuts here. So line joining from this point to this point will give you the beta angle. So this is beta, which is more than this angle 45 degrees. So this is the procedure of finding beta. Now you forget about this line. This is now the inclination. At beta you have to redraw this view. So go for drawing that line. So extend that line. Okay, so this is the axis line where you have to incline with this beta, which is more than 45 degrees, not at this. Okay, so this is, now you forget about this line what you have drawn. Let it be very thin when you draw after finding this beta angle. So this is my axis line where you have to redraw this so that this axis coincides here. So then for this axis line, and from this end point I can take this length on this and I can go for drawing this 1A or 1, 2, 3, 4. I can inscribe this in 1, 2, 3, 4 rectangle. So this will be 1 and this will be 2. So I'll draw a line perpendicular to this axis line, because this line is 1, 2 is perpendicular. So now these two are perpendicular. So anyway, this length I can mark here, taking off of this on either side. I will get this length, same length here. Then I can complete this 1, 2, 3, 4. Anyway, 2 to 3 I have that. Okay, so I can perpendicular on this line perpendicular which is drawn. I can take that length, then I can complete this rectangle. Then A, B is on 1 and 2. C is at this distance on this line. Okay, so from this 1, 2, I'll take that distance. I'll mark that point as C. Then C1 is on this 3, 4, right? Okay, exactly at the axis line. Okay, so then 4 to A1 I can take and I can transfer here. 4 to A1 is same as 3 to B1. Right? 4 to A1 is same as 3 to B1. So I can transfer, I can get the other 2 points. See, easy for me to redraw the same view here. But it's looking different. But when you draw neatly, you can get that view. So same view. This side is visible, outermost edges are visible, and this is the total same thing you draw. Now you have to get this view. For that, you project all these points. Okay, A, C, O, and B. Project all the points. Draw locus from all the points. C, O, A, B, C1, O, A1, B1. Then you have to locate all the points now. So A and check out where is C. So this is A and A dash. B and C, B. This is C, projector of C and C. So this is C dash. So A1 and A1 is on XY line. So this is A1. B1 is on XY line. So this is B1, projector of B1, and this locus of B1 which is on XY line. Then C1. So at this height, okay, same height I'm transferring to get that C1, O1 and O. So now look from the in the top view. So this end is nearer to you compared to this. So this is visible end face. Complete that end face with a thick continuous line. Go for the outermost edges. So once you draw this area now is a visible surface. Now any edges which are not joined will be a dotted line. You cannot have a dark line on the end face. So A1 will be a dotted line. Then this is a surface. You cannot have a thick line here. So it should be a dotted line. So draw a dotted line. That completes your view. So this is how you want to take the beta. Okay, I'll stop here.